Welcome to P4. Today we're looking at representing vectors, unit 7.2. Now, this is still very much the GCSE level of vectors, things that you would have done during your GCSE or IGCSE. But since that was 2 years ago, most people have forgotten, so it's very useful that we still go through these and just make sure you are kind of back up to speed with the terminology and how the kind of basic vectors work. Our focus for this particular video is on column vectors and unit vectors. So a column vector is a vector that's written in this form. If you remember back, again, you would have seen this, experienced it at GCSE, IGCSE level. So it's about your horizontal direction and your vertical direction. So the top one is your horizontal, your bottom one is your vertical. So think of it like this, it's going right and up, certainly if it's positive, or let's put them as a right and left or an up and down. Okay, and you've got positive is right and up, negative will be left and down. If you think of your X, Y axes, positive numbers move to the right, negative numbers are going to the left, positive Y values are going up, negative Y values are going down. That'll hopefully help you remember this. So if I have a vector, let's call this vector V, V for vector. If I have, say, 5, 7, that means it's 5 to the right and 7 up. So this vector V would look something like this, roughly drawn, and it's 5 to the right, 7 up. If I have a vector, let's call this one B, minus 2, minus 1, for example. That means it's 2 to the left, 1 down. And that's my vector there, vector B. Okay, hopefully that's quite straightforward. I'll do another one just to make sure. Let's go, go minus 3, 2. So that means it's 3 to the left and it's 2 up. Okay, 3 to the left, 2 up. And that's C, I should put the minuses in there really. And that is essentially what a column vector is. Now, if I multiply the column vector, so, if I take, say, my vector C here, which we'll use the same one, and I make it, say, twice as big, so 2C will be 2 times minus 3, 2, which will be the same as minus 6, 4. So that would be minus 6 to the left, 4 up. And that will be the vector 2C. Okay, it will just be the vector C plus another vector C. Okay, now we're often going to see this written with a constant or a scalar value that you multiply by, which will be lambda. Okay, lambda is usually used in vectors, and then as a second value constant, if we need a second one, we often use mu. Okay, but if I'm just using one, it's usually going to be lambda. So lambda p times q would just be lambda p, lambda q. You just multiply them. So that's kind of how you would write it in terms of algebra, what we've just done here. Now, sticking with the vectors we've just been using, imagine I wanted to add vector b to vector c, or vector b plus c. Then all that is me adding my column vectors. So this is the same as minus 2 plus that negative 3, minus 1 plus that positive 2. So on the top we'd get -5, and on the bottom we'd get 1. So this column vector is, you can see, 5 to the left, 1 up, and there's my vector b plus c. Okay, very straightforward. And you can also mix in, some scalar ones as well, where you're multiplying. So let me just get rid of that. If I was thinking of 3b minus 1c, for example, that means it's 3 lots of b minus 1 lot of c. So you think about this is -6 over -3, and then we've got to take away -3 on the top, and we're taking away 2 on the bottom. So -6 plus 3 is -3, and -3 minus 2 is -5. So then we get a vector which is 3 to the left, 5 down, and then this is the vector 3b minus c. Okay, and that's kind of combining everything together. So in terms of algebra, we have lambda pq is lambda p times lambda q, because you're multiplying, and say pq plus rs is p plus r q plus s. Okay, very straightforward, hopefully easy to understand. Now the next thing we need to look at is unit vectors. Okay, these are very important. We actually use these quite a lot in vectors. You'll be experiencing them quite a lot, and it's all about essentially 1 unit of length in a direction that we know. So talking about this, if I take here, if I look at the x direction, a vector in the x direction of size 1 is vector I. A vector in the y direction, also of size 1, so it hits the 0, 1, this is vector j. Okay, it's all about the direction and that size, so it's just of unit 1 in length. Okay, so if I think about a vector that is 2 units in length in the x direction, it would be 2i, and it would actually hit the coordinate 2, 0 if it was from the origin. Okay, hopefully that makes sense. We'll go into a little bit more detail. Now later on we will actually bring in the 3rd dimensional, ij, and you probably guessed it, k in the 3rd dimension, but for now we're just sticking with I and j. So if I think of I in terms of a vector, that would be 1 across 0 up, and j would be 0 across 1 up. If I think of vector c I had earlier, which was -3, 2, this could be written as -3i plus 2j, as it's 3 units to the left and 2 units up. Okay, so when I'm writing that, if I think of this vector, let's go like this. This vector c here is -3i and 2j. Okay, very, very straightforward, hopefully. Okay, it's just that I and that j just stands for 1 unit in length. And in the next video you'll be looking at what length is in terms of magnitude and stuff like that. So just in terms of algebra, like we did with the others, if I have the vector PQ, that means it can be written as PI plus QJ. Now, let's have a look at our first example. We've got two vectors, vector A, which is 2i minus 5j, and vector B, which is I minus 4j. And the first one we want to find 2a. So a couple of simple ways of approaching it. 2a, just want to multiply everything by 2. So 4i minus 10j, nice and easy there. You could also write it in terms of its vector. So 2 multiplied by 2 minus 5, which is 4 minus 10 as a vector. Now, unless it specifies in the question, certainly in terms of the answer, you can write your vectors in I and J format or column vector format. The choice is yours. Personally, when I'm doing calculations and things within vectors, I tend to use the vector format just because I find it so much quicker and easier than writing out I, J, and K when I'm in three-dimensional, when I can just put them in a straight line like this. So when you get lots of vectors that you're dealing with, column vectors tends to be the easiest way. Often though, we'll put the answer in terms of I and J or I, J and K later on in this unit. Right, let's have a look at B. We've got A plus B. So I want to add my i's. So you can see here 2i plus I is 3i. And then our j's, minus 5 plus minus 4 is minus 9j. And then C, which is 3a minus 2b. So we get 3 lots of A, which is 2 and minus 5. I'm going to write this in column vector. Minus 2 lots of B, which is 1 and negative 4. So I get 6 over minus 15 minus 2 over minus 8. Now you can see it's quite easy now. 6 minus 2 is 4. And then negative 15 minus minus 8. So negative 15 plus 8 is negative 7. And then of course I can write this as 4i minus 7j. And then finally part D, we've got 1/3 A plus B. Well, we've already worked out A plus B in part B. So this is 1/3 3i minus 9j. Okay, which you can see is 1i minus 3j. And as I said before, another way of writing this would be in vector format, column vector format, I should say, to be more specific. So we've got 1 and minus 3, or I minus 3j. Okay, so you can see it's quite fluid where you can switch between column vectors and unit vectors. Okay, most answers are often in unit vector form, but most of your working out is usually easier in column vector form, especially not so much in here, but as the questions get more complicated later on. Now, since this covers kind of all the basics, I'm going to get stuck into a few questions, start you off with some easy, straightforward ones like this, and then I'll throw in a few slightly harder ones later on. Now, first of all, I've just done a plus lambda b, so a plus 2 times lambda, and then for the j's we've got 2 minus 3 times lambda. Now, if it's going to be parallel to ij, then what that means is that these two have got to be of equal size. So therefore 6 plus 2 lambda must equal 2 minus 3 lambda. I can now solve for lambda. Now with this one, you can see it's equal to I plus 2j. We can see that the j value's got to be twice the size of the I value. So if I want to make them equal so that I can solve, I actually have to times the I1 by 2 and then make it equal to the j1. So that would mean that I get 2 lots of 6 mu plus 2 equals 2 mu minus 3. Okay, so I'll just repeat that again. The j is going to be twice the size of I. So if I want to make these equal, I would have to multiply the I by 2. And from here then I just solve. Now with this one, it's parallel to minus I plus 3j. So to think, if I want to make these equal in size, I'd have to multiply this one by minus 3. And then it would be minus 3i. Sorry, it'd be positive 3i. And therefore it'd be the same. So that's what I need to do here. So we get minus 3 times my I, and then it will be equal in size to the j. And then I just solve. Now, you can double check all 3 of your answers. If you use this and substitute back into your I and your j, you should see, in this one, they should end up being the same value. In this one, your j should end up twice as big. And in this one, your j should be 3 times as big and positive, whereas your I would have been negative. Okay, so just use that to double check. Now, in this one, we can now say that the horizontal ones, so the I values, have got to be equal in size. So this must equal this, and the same for these j values. So that means that 9 minus r must equal 2, and t minus 5 equals negative 3. And now I just solve for both. The resultant of vectors a and b just means a plus b. So that's 3 plus p, and 1 plus 2p. And then these are going to be parallel to this vector here, c. So 3 plus p, 1 plus 2p. Now if it's parallel, it could be any length of this. So we really need to put in this value of lambda, or you can use mu. It's up to you. So we get 3 plus p equals 2 lambda. 1 plus 2p equals 3 lambda. Now we've got two equations and two unknowns, so it's about solving it. So if I take equation 1 and times it by 2, I get 6 plus 2p equals 4 lambda. I'm going to call this equation 3. And then I'm going to do equation 3 subtract equation 2. So that is, I'll write these out again so you can see them. So that's equation 3, and equation 2 looks like this. So 6 minus 1 is 5, 2p minus 2p is 0, and 4 minus 3 lambda is 1 lambda. So lambda is 5, then sub this into, let's go into equation 1, we get 3 plus p equals 2 lots of 5. 3 plus p equals 10, so p must equal 7. So that is their part A done. Now part B, we need to find the resultant, and we know that p is 7, so very simply 3 plus 7 and 1 plus 2 lots of 7, and that is 10, 15. Okay, so what you can see is that this is the same as obviously C, but it's a multiple of it. It's 5 times the size, as that's what that lambda was. If you remember, we had also had this equation, 3 plus p, 1 plus 2p, and that was equal to lambda to 3. So the alternative way was, we knew that lambda was 5, so 5 times 2, 3 gives me 10, 15. So the same vector. Okay, so it's the same as vector C, it's just 3 times the size, so it's like 3c essentially. Hopefully you found this video, or at least some aspects of it, useful. The next video is on magnitude and direction, so stay tuned for that. That should come up in a couple of days. And if you haven't subscribed so far, just consider hitting that subscribe button and helping us out. Cheers.